All right, secant. I don't like dealing with secants. I like sines and cosines. So let's change this to cosine. So again, the angle goes along with it. So it's 1 over cosine of 3 theta is negative 2. So let's cross multiply. So that's same as saying cosine of 3 theta is negative 1/2. Okay, so think about where that is. Where is the x value? Negative 1/2. So the x value is negative 1/2 here and here. So that means that the angle 3 theta is going to be here, which is 2 pi over 3 plus 2k pi, or the angle is going to be down here, which is 4 pi over 3 plus 2k pi. Again, divide through by 3, so then I get 2 pi over 6 plus 2k pi over 3, and dividing this by 3, I get 4 pi over 9 plus 2k pi over 3. And those are great answers. You could simplify this, I know, but it doesn't matter to me. Okay, let's think about tangent. I like to think of tangent in sines and cosines. So that's sine of 3 theta over cosine of 3 theta is 1. So that means the x and the y value have to be the same number to get a 1. So what does that mean? I think that means I'm going to have this pi over 4 guy or this pi over 4 guy. And you notice that these are pi apart from each other, right? Okay, so that means 3 theta will be, go to the angle of pi over 4 and add k pi. So here pi over 4, add pi, add pi, add pi. Okay, now I'm going to divide through by 3 everywhere. So I get pi over 12 plus k pi over 3. And that's a great answer. If you didn't notice they were pi over 4 apart from each other, you could say 3 theta is pi over 4 plus 2k pi. 3 theta is 5 pi over 4 plus 2k pi, and divide. It's okay to have more answers, just as long as you can identify what my answers are. All right, cosecant squared. I need to take the square root first, right? Wait a minute. It's got a negative, so there's no solution because I can't take the square root of a negative number, so that one's done. Ooh, this looks challenging. So I've got 3 terms, so it's not as easy as what I've been doing, but if I presented you with this problem, could you factor and solve? You'd say, yes, x plus 2, x plus 1. So what's the x in this case? The x in this case is cosine. So I have cosine, cosine, and I'm going to add 2 and add 1. So if I multiply this out, it gives me this trinomial, right? So here we go. So cosine of theta is negative 2. Cosine of theta is negative 1. So cosine of theta, when is it negative 1? Back here. So theta is pi plus 2k pi. And when is cosine of theta equal negative 2? Never, because we're talking about the unit circle, right? Okay, let's look at this one. Ooh, so you'd think maybe with the trinomial it's similar to this, but it's not. We've got cosecant. So what do we do with cosecant? I always change it to sines and cosines. So let's rewrite it in terms of the sines. So, I don't like fractions. So in order to get rid of fractions, I'm going to multiply both sides by sine of theta. So if I distribute as I go, so I get 2 plus sine squared of theta minus 3 sine of theta equals 0. What do I do with that? I know. Let's rewrite this. Minus 3 sine of theta plus 2 equals 0. If I just put the powers in descending order, sine squared, sine to the 1, onto 2, let's see if I can factor and solve. So again, sine is my x, right? So sine of theta, sine of theta. So what two numbers multiply to positive 2 and add to negative 3? Negative 2, negative 1. So here I get sine of theta is 2. No solution. And sine of theta is 1. When does that happen? Theta is equal to pi over 2 plus 2k pi.